Hello everyone, welcome to Coders Camp, and today we are going to cover another interesting problem: replace the substring for balanced string. So here the input given is a string. We have to return the minimum length of a substring we can replace to make the string balanced. String is said to be balanced if each of its characters appear n by 4 times, where n is the length of the string, and the only four kind of characters will be present in the string, that is Q, W, E, R. So let's understand this with an example. Here is our example string yes. So the length of the string is 8. So we need to have each character of length 8 by 4, that is 2. So we should have 2 Qs, 2 Rs, 2 Es and 2 Ws. So here if you observe the string, our string is having 4 Ws, 2 Qs and 1 R and 1 E. So now we have to replace any substring to make the word balanced. Balanced in sense all the word should have maximum of 2 characters present. So let's see what are all the possible solutions for this problem and then decide which one is optimal. So first let's try updating the first substring starting from W to W. This can be updated like, and the rest of the characters are same, E, Q, W. We just replace the first 5 characters to this so that now our string is balanced. That is, we have 2 R's, 2 E's, 2 Q's and 2 W's. So next we are going to try and replace other substring. So now in our second output we have replaced last 4 characters from the given string and updated the string. Now the string is again balanced with all characters appearing twice. So now finally we have updated the characters WRR of size 3 and updated them with ERR to make our string balanced. So now if you check our first solution, we have changed substring of length 5 to make them balanced, and in the second solution the substring length is 4, and finally we changed substring length of 3 and made our string balanced. In this case, the last solution is the optimal or took minimum length substring to update or replace the characters to make the string balanced. In this case, 3 is going to be our output. So how are we going to approach this programmatically? When I always hear length of a substring, the first thing that gets to my mind is sliding window. So here we are going to use sliding window technique to find our substring that is to be replaced to make our string balanced. So we are going to get the help of hash map, where our hash map is going to hold the occurrence of each character in our substring or in our string. So this is our hash map at initial point of view, where it stored the occurrence of each character in a given string, and our target is 2, that is length of the string by 4. So each character should appear maximum of 2 times in the string so that the string is said to be balanced. So first we are checking in our table whether the string is already balanced. In this case we have 2 extra W's, so our string is not balanced. So what are we going to do? We are going to have 2 pointers, left and right, starting at our initial index. So now we are going to move our right pointer every time as a scanning agent and check if the substring within that limit can be replaced to make the string balanced. So let's have a dry run for the given example and you'll get a better understanding. So now our right pointer is at our first character W. We are going to check if we replace this W and make our string balanced. In this case, if we are going to replace W, then the count gonna decrease, because if we replace W, the option will be either Q or E or R. In this case, W will not exist. We are going to remove one W and put some other character in the place. In that case, if we remove one W, the count becomes 3. So now we are checking if our string is balanced or not. No, our string is still not balanced because we have one more extra W. So what are we going to do? We are going to move our pointer R. So now we have moved our pointer R to our second character, and we are going to check if we replace the characters from left to right and make our string balanced. In this case, we are going to replace W and Q with completely two different characters and update our hash map. So what do? We reduce the actual value of W and Q in our hash map and check if our string can be balanced. So now after moving our R to Q, our count in our hash map becomes W to 3 and Q to 1. We are now checking whether our string is balanced. No, our string is still not balanced because we have extra W. So let's move our pointer R. Now that we have moved our right pointer, we are going to check whether replacing this substring from left to right will make our string balanced. In this case, we already have updated one W and one Q. Now let's update our third W and check whether our string can be balanced. So we have updated our W to 2. In this case, if you check, it meets our condition that any character can be maximum of 2. So our string is now balanced. So the string length we have replaced is here is 3. So now our output is going to be 3 as of now. So now we are going to move our left pointer to check further if we can optimize our length of a substring. We have moved our left pointer to Q. Now we are going to check whether replacing the substring of length from left to right will make our string balanced. In this case, we have left our W, so we have reduced the count of W in our map to keep track of our substring occurrences. But since we have moved our left pointer, now we have to increment our character count by 1 because it has not been included in our substring window. So now the count is 4. We are checking whether our string is balanced or not. No, our string is not balanced because we have extra W. In this case, we cannot move our left pointer and optimize our solution. So we are again going to move our right pointer. Now we have a right pointer at R. So we are going to check whether by replacing the substring from L to R will make our string balanced. So as I have moved my R, I have updated my R to 0 because we had only one R in our string, and as we have going to cover that inside our sliding window, substring window, I have updated it to 0. Now we are checking whether our string is balanced or not. No, it is not balanced because we still have one more W left. So in this case, move the right pointer. Now we have our R at W. Now we are going to check whether by replacing the complete substring, we get a string balanced. As I have moved R, I have updated my W to 2. So in this case, we are checking no strings occurrence is greater than 2, so our string is balanced by replacing the substring QWRW. So the length of the substring is 4. Already our output was 3, and now we got a new output 4, but which is minimum. 3 is already a minimum value, so we don't have to go for a higher value, so we are sticking to 3. So now we have found our new substring that can be replaced. We are going to check whether we can further optimize this substring window to make or reduce the length of the substring. So it's time to move our left pointer. So as we move our left pointer to W, we are going to check whether replacing the substring from L to R make our string balanced. So we have omitted Q before left pointer, so we have to increment Q as we moved our left pointer. So now we are checking whether this substring replacement will make our string S balanced. Yes, it is balanced because no occurrence is greater than 2. So in this case, we have found another substring that can be replaced to make our string balanced. So the length of substring is again 3. We have our 3 already as our output, so there is no change in our output. So now it's time to move our right pointer. As I moved R to E, I have updated E to 0. Now checking whether our string is balanced. Yes, it is balanced. So our new substring is of length 4. Since 4 is greater than 3, we are not updating our output. Now time to move our left pointer. So now our substring is RWE As we have omitted our W from our window, we have to update W plus 1. In this case, our string is not balanced, so we have to move our right pointer again. As we have moved our right pointer to Q, we have updated Q to 1. So now we are checking whether our string is balanced. It is not balanced because we have extra W's. In this case, move R again. Finally, our R moved to W. We are going to check whether the substring from left to right makes the string balanced. Yes, by updating the substring left to right, make the string balanced as we have updated the count now. So it's time to move our left pointer to check whether we can further reduce the length of the new found substring. As we have moved our left pointer from R to W, our count of R updated to 1, and now let's check whether replacing the substring WEQW will make the substring balance. Yes, it will make the substring balance. So we found a new substring of length 4. Since the output is 3, we don't update 4. Let the output be 3 now. And now move the left pointer furthermore to check whether we can reduce the length of this substring and make the string balanced. Now that we have moved our left pointer from W to E, let's update the count of W to 3 and check whether it makes our string balanced. No, it will not make because we have extra W's. So in this case, we have to end our iterations because there are no more elements left next to R to move the pointer, and further moving L will not reduce our size of substring. So finally, our output is going to be 3. So generally, sliding window of not fixed length substring will run by the time complexity of n plus k minus n, and removing the constants, finally it is gonna run in order of or big O of n time complexity. So now let's go code it. As we have seen examples already, let's dive into coding. Here is our code, and you can find this code in my blog, which I have given in my description. And I have started initializing my hash map to hold the occurrences, and my target is the number of characters the string can hold to be balanced, that is the length by 4, and the minimum length I'm initiating to the maximum length, that is the length of the string, and finally we'll update it with the length of the substring we find. And I'm gonna have a for loop and put all the occurrences in my map. So once that is done, I'm going to check whether the string is already balanced. If it is balanced, we are going to return 0. If not, we're going to initialize our pointers right and left, where right is going to scan from index 0 to length of the string, and we are going to decrement the count of the character where we have our pointer right. That is, this is going to decrement every time we move our pointer R, that is the characters inside the substring, left to right. If by decrementing it our map becomes balanced, then we are going to calculate the new substring length and update the minimum length so far. After that, once we found our substring, and we are going to iterate our left pointer and increment the count of the character before the left pointer, and after incrementing it, we are going to check if the map is balanced. If the string is balanced, then we are going to update it with a new length. If not, we are going to simply break to increment the right pointer or move the right pointer. So by moving the left and right pointer, finally our output will be updated in this variable minimum length, and we are going to return it. So we have another helper method, that is balanced. It is going to check in map if there is any entry value greater than target. If that is the case, it is returning false, otherwise it is going to return true. So this is our code. Let's submit. So yes, our solution is accepted. If you see, this is quite a slower solution than other solutions submitted, but the same concept, the same idea can be implemented completely in arrays without any help of hash map. So that will actually reduce your execution time so much. Just for better understanding, I have used maps, but you can implement the same solution by using arrays. So thanks for watching. If you want the solution from arrays to be explained, please comment below. I'll make another video using arrays. Thank you.